Welcome to the notes on equations of lines and graphing. By the end of this lesson, you're going to be able to graph lines in slope-intercept form. So there we go. There is slope-intercept form. Y by itself equals mx plus b. Remember m, all right, why do we call it m? Because that's how you move on the graph. Why do we call it b for the y-intercept? Because that's where you begin when we're graphing. Okay, and remember the y-intercept, all right? That value we always call it's a point, all right? It's the y-intercept point. And it's the ordered pair. It's always a 0 for the x. We'll talk about that in a second. And then that second, the y value is your y-intercept, b in this case. Okay, for slope, remember, it's rise over run. Rise over run, which again, rise refers to the y, run refers to the x-axis. Okay, below, how are we going to use that in the graph? Below we have our xy plane. Remember that this right here is our x-axis, and the vertical is our y. So how many points do you need to graph a line? Well, you need 2 points. You have to have at least 2 points. So we can graph an equation of a line as long as we have 2 points. So let's take a look at a graph here. Let's say I put a point here, and I put a point over here. Okay, that's all I need to make a line. Now I draw my line through those 2 points. Okay, and you can see that has a positive slope because left to right, it is on the rise. So where is our y-intercept? The y-intercept is where it crosses the y-axis. Okay, so why do we put a 0 there for the y-intercept point? Because that ordered pair is 0, 2. And if you pick any point along the y-axis, all right, pick this point right here. Pick this point right here. This is going to be 0, 6. This one right here is 0, 4. Okay, down here, all right, if that crossed the y-axis down there, it'd be 0, -4. So anywhere on the y-axis, and the x value is always 0. That's why the y-intercept point is, we put a 0 there automatically because the x value has to be 0 when you see for the y-intercept. So if you see an ordered pair with x is 0, you know that's the y-intercept. Now, if we want to count the slope of this line, we would just count up. How much do we have to go up? We have to go up 1, 2. So this would have a rise of 2. And then how much do we have to go over the run? We have to go over 1, 2, 3, 4. So it's over 4. So the slope would be rise over run. So m would equal, if we reduce that fraction, 1 over 2. Okay, now that we know how to kind of have an idea of how to graph where the y-intercept is, let's actually graph some lines using slope-intercept form. So here are the types of problems you're going to see. Now this first one is awesome. The equation is y equals 2x plus 1. It's already in slope-intercept form. Y is by itself. We've got the slope as the coefficient in front of x, and then our y-intercept is right here, our y-intercept point. So now that slope is just 2. Okay, it's just 2. There's no number. It's not a fraction. Well, remember, every whole number, it's really over 1. So in this case, our rise is positive 2, and our run is 1. And since they're both positive, that's positive is up. Okay, positive is up. All right, and then for positive in the x, that is to the right. If you had negatives, so a negative for the y would be down, and negative for x would be to the left. Okay, because the number lines. So just keep that in mind when you're graphing these points. Now, and then our y-intercept, that is the point 0, 1. All right, because that y-intercept at positive 1 right here. So there's our y-intercept. Okay, now how are we going to graph? We start at the y-intercept. We don't have an initial point. We just count using our slope. Up 2 over 1. So I'm literally just going to count from this point up 2, 1, 2 over 1. There's another point in the graph. I count up 2 over 1. There's another point in the graph. Up 2 over 1. There's another point. Now, I could also call this -2 over -1. I can move the other direction because remember, 2 negatives makes a positive. So watch what happens. I'll do that in green here. I'll start at my y-intercept, but now I'll go down to -1 with negative and axis to the left. There it is, down to -1. There's another point. And you see when I connect these, they're all on the same line here. So there is my graph of y equals 2x plus 1. Y-intercept of 1 has a positive slope. It's going up to the right. Let's take a look at another example. Now this one you notice is not in slope-intercept form. So the first thing we have to do is we have to get it into that y equals mx plus b form. So to do that, we've got to solve for y. So first thing I do is we want to get y by itself. We don't want this 2x over here. Minus 2x minus 2x. So we're going to be left with 3y equals, now we talked about this yesterday because it's in slope-intercept form. We want the coefficient with the x in front of the constant. So we're going to write minus 2x minus 6. We're one step away. We want to get rid of that 3, so we got to divide by 3, which cancels that up. But now we have to divide every term by 3, not just one. It's a common mistake. So we're left with y equals negative 2 thirds x. Negative 6 divided by 3 is negative 2. So now that we're in slope-intercept form, we can see our y-intercept point, and we can see our slope is negative 2 thirds. So let's put our y-intercept down 2. Okay, now the slope of negative 2 thirds. I get a lot of questions. Is that negative at the top? No, the numerator of the denominator. It actually doesn't matter. You can only give it with 1. So you can either write it as negative 2 over positive 3 or 2 over negative 3. And I'll graph it either way, both directions. Remember, positive or negative is up, or if it's positive or negative, determines if it's up or down. And positive, negative for the x determines left or right. So we'll graph this one first in blue right here, negative 2 thirds. So the rise is negative 2, so I'm going to go down to 1, 2, but the right is positive, 1, 2, 3. There's a point. Down 2, 1, 2, 3. There's another point. Now I can go the other direction. I can go positive 2, but to the left 3. So up from my y-intercept, up 2, 1, 2, to the left 3, 1, 2, 3. There's a point. Up 2, to the left 3, 1, 2, 3. There's a point. And then I connect, and there is my line. Okay, and you can see, as we look at the graph left to right, the slope is going down. Make sure if you have a negative slope, your graph should match up. All right, and that is all we have for graphing equations of line in slope-intercept form.